All right, this is my project, my data analysis project for project number 2. I'm gonna go ahead and just get right into this. This is my prompt, but to give my prompt a little bit of context, I figured I'd show you guys the database I used, European soccer database. So just some of the key components. There's over 25,000 matches, over 10,000 players, 11 European countries. And this is seasons 2008 to 2016. The list goes on a little bit, but those are some of the key details. So find the top 3 tallest players who were born in the 1980s, weigh less than the average weight of all players, and have a name that contains son, like Johnson or Peterson. Show their names, heights, weights, and birth years, sorted by height in descending order. So that's a really complex prompt. Any LLM would struggle to do that for several reasons. We'll go over that in a little bit. But what I'm going to do is I'm going to highlight this. I'm going to take it over to cursor here. Let's get that a little bit more centered. So in here already I have use Neon MCP to reference my data project to answer the following. It's using Claude 3.7 Sonnet, which is from Anthropic, and then it's agent mode. So let's just see what it does. Hopefully this works. It's been kind of having some trouble. So it's listing my projects. So now it knows to find my data project. And now it's running SQL to answer these questions. I'm just going to let it kind of run here. And boom. There we go. So I'm just going to take this, bring it back to the slide deck, just so we can make it a little bigger. Let's change that. Okay. So one thing that I think is really important to consider here is my question asked it to find these top 3 players that weigh less. Oh, sorry. Gotta go back to that. Okay. Again, what's very important to, I think, consider in this is I never gave it the average weight of the players. There's 11,060 players in this data set. I mean, it asks several questions that would be hard for any LLM to conceptualize, and that's why running SQL is superior. So, I mean, I'm just kind of blown away with this. Again, with how quick it is. Also, it had to find the database. So sometimes when I'm already like referencing the data from a certain project and, you know, one of the databases, it doesn't have to go and find it, list the columns and find. So usually, actually, if I were to do basically the same prompt again, it would go much quicker. So why is this so impressive? Well, large language models are limited by their context window. They can only handle so many tokens at once. Tokens, if you guys don't know what those are, they're not words, they're not characters, but they're just part of a word. Sometimes they're full words, but like a period is a token, for example. And that is, each LLM has a context window. For example, ChatGPT 4.0, its context window is 128,000 tokens. Anything above that, it will just ignore, or it won't be able to even process the entire data set. So SQL has no limit, and it can query huge data sets fast. So it kind of has an infinite context window or infinite tokens that it can process. Just to be clear though, it doesn't actually even have a context window, and it doesn't use tokens. I'm just using that for the, just to make things simple, but basically it's more of like a math structure, SQL is. This data set that I use is approximately 33 million tokens. And again, ChatGPT 4.0, 4.5, its news model, its context window is 128,000 tokens. So there we go. ChatGPT 4.5, 128,000 tokens. Claude 3.7 is 200,000 tokens. There's like Google Gemini, the Pro model. I think it's called Flash 2.0 or something. Its context window is like 1 million or 2 million. So it's very impressive, but still not the same. And then the complexity of that prompt, wouldn't it be obtainable, in my opinion, to achieve through an LLM, at least the current state of them. So why this query is complex for large language models? Well, it involves multiple filters, birth year, name pattern, and weight comparison. It requires calculating and applying an average aggregate function. So, or I guess it's an aggregate function. I'm just reading it right off there. So aggregate functions are hard for LLMs. It needs string matching with names. So Son to Johnson, like it just would have a hard time doing that. And then it must sort by height and limit just to the top 3 results. It relies on precise data structure, extracting birth year from date. Okay, so what is SQL? SQL is structured query language, queries data precisely. This is an example of what it would look like. So select times from players where height greater than 180. And that is just saying find all players taller than 180 centimeters, for example. So generally speaking, when you're using SQL, you have to write out the code, which is essentially like a formula that, like, you know, I kind of think of it like Excel. When you type your Excel formulas and you come up with your answer. It's very similar. So what I used for this project was a data set from Kaggle, which is the European soccer data set. I kind of referenced that in the beginning. And then I used PostgreSQL, I think is how you say that. And I transferred that data from Kaggle into SQL. And then Neon is a database, online database where I can store that SQL data set or SQL, and it also has an MCP server. And then Cursor, which is the IDE I used, and also can host the MCPs, is how I was able to query, and then it referenced Neon for the data. I used Claude 3.7 Sonnet on Cursor. That was the LLM I had selected. So you guys are probably going, what is MCP? Well, this is from Anthropic. They're actually the ones that made the MCP, and they're also the owners of Claude, and they're kind of the lead, I would say, LLM for coding. But anyway, this is their definition. MCP is an open protocol that standardizes how applications provide context to LLMs. Think of MCP like a USB-C port for AI applications. Just as USB-C provides a standardized way to connect your devices to various peripherals and accessories, MCP provides a standardized way to connect AI models to different data sources and tools. So think of this like, if you're a student at Boise State, we have Canvas, right? And all of our homework is on Canvas usually. And if you were to ask like ChatGPT, be like, what homework do I do in X class or all my classes? It would say, I have no idea. Like, give me some more context. Well, with an MCP, it would just call a Canvas MCP, look inside of your Canvas, and maybe see your calendar and go, okay, you have these projects coming up these days, and they're due this time, and this is what they are, etc. So it's just connecting an external source to your LLM. So this is kind of my visualization. I took the Kaggle data, transferred it to SQL, uploaded the SQL to the Neon, which held the data set, and then Neon has an MCP server, so I connected that server to the host, which is my IDE Cursor. Hopefully I didn't say that. I feel like I said Cursor twice, but so as a result, I can query big data using human language and get results fast, accurate, and reliable. And that's not really obtainable with LLMs. If you were to just upload a big data set, like I said, they wouldn't have been able to even take this one in. So I think that this is the future of data analysis. And for the reflection, how did AI help you in this project? Where was it most useful? Definitely using Grok, just to Grok is XAI's LLM. I just asked it questions as I went. It kind of helped me walk through it. I provided lots of context of what I was doing. So it's kind of like a slow back and forth, but truly you learn so much in the process. It's really cool. I've never done anything like this. I've never used SQL. I had to use the terminal, just new stuff. So it was really cool. Where did AI fall short? I don't even know how to answer this. I feel like I didn't. It always amazes me what it can do. I guess I would just say that when you're using the terminal and you're downloading all this stuff, it's directly on your local computer, and it kind of looks scary if you don't know what you're doing with it. And, I'm not very experienced with all this. So, like, you just got to make sure, like, read it, make sure nothing weird is being downloaded or deleted, just because, it could technically go south. But it did not in my case. How do you see AI fitting into data analysis? My example, that's how I see it, is people being able to use human language to query large data sets rather than needing to know SQL to query. So I think this is your guys' first look, if you haven't already seen anything like this, first look into the future of data analysis with AI, you getting reliable results through SQL. So that being said, that is the end of my presentation. Thanks for tuning in, and I'll see you guys next week.